Hello, in this particular lecture we're going to have a look at game AI. It's going to be very much an introduction to the subject, and we'll compare and contrast it with traditional forms of AI, and then look at some of the things that are important for games AI. So we'll start off initially really by talking about artificial intelligence in the broadest sense, and we'll then tease out from that what exactly game AI is about and some of the important characteristics that we'll want to introduce into our games to make sure that we have an enjoyable AI experience within the game. So artificial intelligence as an overall aim is all about enabling computers, programs, devices to behave in a way that we would classify as intelligent. It's quite a large area of research within computer science, and a lot of the practitioners, they sort of kind of fall into one of two different camps, if you like. One is strong AI, and this is about producing artificial intelligence that models how we think, so that it's cognitively plausible. So this is trying to look at the brain, how does the brain think, and then trying to reproduce a similar structure on a CPU using whatever software forms are appropriate. In contrast, weak AI, that is all about how do you create an AI that does something useful that we would look at and go, yep, that's intelligent, it's good behavior, but it doesn't matter behind the scenes how you do it. If it's not plausible, if it's not how we think, that's somewhat irrelevant. It's more about the results that are generated. A lot of academic AI is focused on doing something to the best ability possible. And if this means doing it to a level of ability well beyond what a person can do it, that's a positive benefit. Game AI is a bit different. Next slide we're going to have a look at some of the desirable traits of a game AI. But one of the things to note here is that game AI is only one of the things that's ongoing within your game. It generally is a real-time experience, so there are quite often tight memory constraints, CPU constraints within which game AI must operate. As to the aims of the AI we would have within games, got a list of them here. It has to appear intelligent, obviously, yet purposefully flawed. So we want our games to provide us with an engaging experience, but not one that's going to routinely beat us. Ultimately, we want to come out on top. I think that sort of speaks volumes about us as a species, but nonetheless for our AI, yes, we want nice AI, but we want to be better than it. For a game AI, it's important it has no unintended weaknesses, and here we're thinking about a particular strategy or approach that the player can take or adopt, and if they routinely take that position, then they'll always win or always exploit a weakness in the AI. It's a game. Games are there to entertain us, to engage us, so we want our artificial intelligence within our game entities very much to provide entertainment and engagement. As mentioned, it has to perform within tight CPU and potentially memory constraints. It has to be configurable, so that ideally we want to create it in a way where we can tweak the difficulty of it or modify it. That means we can go to our user group, we can test out different types of AI behavior on them and pick the one they like best. Must finally not keep the game from shipping. So games are quite often about pushing the boundaries forward, about making better games, more capable games. Sometimes that comes down into the sophistication of the AI. We want to make sure if we are doing that, but we do so in a way that doesn't, it doesn't introduce undue risk into the game. That the AI, we don't have a game that's reliant upon us creating a new form of AI that's never been done before. There's a few things that actually will help us when we're creating AI, and one of the main things is that we, humans, we are configured, we're wired up to see intelligence in a lot of different aspects. And generally for us, if something behaves in a complex manner, and that complexity is human-like, so it's the type of behavior that a human might engage in, we very, very rapidly perceive it as being intelligent. And conversely, if it behaves in a simple or a manner that isn't human-like, then we're very often quick to reject it as being intelligent. And quite often if you have something with a simple set of rules with a little bit of random variation just thrown in, so it's random change, there's no intelligence behind it, we will perceive it as intelligent behavior. We're going to be inclined to try to interpret it as if it was done by a complex, intelligent entity. And this really ties into, I suppose, how the brain processes information. There's probably one of my favorite sort of visual illusions, where we have, in this case here, two squares, A and B. And looking at it, A appears to be sort of a dark grey, B appears to be a light grey. In reality, they are exactly the same colour. If you were to cut this out or to a screen copy and move A next to B, you would see that they are identical in colour. But nonetheless, our visual system is set up to perceive them in certain ways. And there's a degree of truth also in terms of how we are inclined to perceive behaviour as being intelligent, particularly if it's human-like, particularly if it's complex. So as a reasonably good working definition of game AI is anything that contributes to the perceived intelligence of an entity. Doesn't matter what's under the surface. So it's very much sort of weak AI in terms of the previous definitions. You could go through a few exercises here and think about, well, is it AI or is it not AI? So things like, what about a single if statement? Does that constitute intelligence? Most people will go, probably doesn't. What about scripted behavior, where you have a series of, well, if this is true, then you should do that, and if some other thing is true, you should do something else. It's one of the sort of staples of traditional game AI. A lot of people, maybe this constitutes AI, but all it is a combination of if statements. A character selecting which animation it's going to play may or may not be, depends upon the complexity of the decisions that need to be made. Pathfinding, finding the location from one start point to the end point. Most people would perceive that, yes, that's artificial intelligence, even though it's just a simple search algorithm that's been executed. And finally, if you have a game that creates a level from scratch or creates a nice map from scratch, most people wouldn't classify it as artificial intelligence, though out of the activities we've identified here, it's probably the most complex thing that can be done. There are lots of particularly interesting philosophical or moral or ethical questions that sit around this area, and one is about Searle's sort of Chinese room argument. A lot of this is about, well, what happens if game AIs keep improving and become more capable and more impressive? Could they ever improve to the point where they become self-aware? Could you have entities within a game that are self-aware? And if so, what are the implications on creating and on playing games within which you have such a type of artificial intelligence? Searle's Chinese room argument is a question about, well, what does it take actually to create a system that does have self-awareness? And what does self-awareness actually mean? And at what point does it emerge, and what type of system does it need to emerge from? All quite interesting questions to ponder. Next thing we're going to have a look at is the notion of an AI engine. They generally only occur in large systems, though we're looking at it here because it gives us a way of grouping and clumping together different types of AI techniques, and we'll look at a number of these in the lectures over the next few weeks. So most of the games that you're writing, you don't need to have an AI engine. It generally is something that emerges as your game gets bigger and bigger. For the stuff that we're doing, you may have an entity, it'll have an update method. Within that update method, you'll encode whatever AI or behavioral aspects are appropriate to that particular entity. In large, complex games, I suppose you get into a situation where you have more to manage, where you'd realize, oh, well, you're doing this and you're also doing that. I can maybe take that out and abstract it together into some notion of an engine. So you're not obliged, you don't have to implement an AI engine in your game if you want to, but if you do, by all means, feel free to introduce one. So here we have an illustrative structure of one form of game AI engine, and we're defining a number of different groups between strategy and decision making and movement. The higher level forms of AI generally are ones that we would classify as appearing to groups of objects. They decide how a group of objects should act or behave. Lower level forms of AI generally apply at the level of an individual entity, deciding how that entity will make decisions or how it's going to move about within its environment. Alongside this, there's some notion of execution management. This gets into the idea that within a game, you may have a number of different AI objectives that you're trying to achieve, and you'll be given a slice of time within which to achieve those particular objectives. And you can get sophisticated here in terms of prioritizing what's most important to do what things to what extent. That can all fit within execution management. AI, it doesn't sit on its own. It needs to query the world. It needs to find out things about the world to enable decisions to be made. So our AI engine needs to have some way of getting access to whatever other bits of information that it requires for its decision-making routines. And in terms of the output, again, it is there to drive behavior. So that may be changing the animation, it may be changing characters, but the AI engine needs to have a way of outputting its decisions so that they can be acted upon or implemented by whatever is relevant to do so. So movement is one of the bottom level ones. There you've got a whole range of algorithms that make decisions about how an object can move around within its environment. We're going to look at quite a few of these. A lot of them are actually quite simple individually, but there's lots of nice ways they can be combined together to give fairly sophisticated forms of movement. Next level up is decision making. Here we're saying that a character in the game has a choice. At any point in time they can maybe take one of a number of different types of action. Action may be moving about, it may be implementing or taking or putting into effect one of its abilities. Decision making is all about, well, what's the best action to pick at a particular point in time? And we'll have a look at a number of different decision making techniques that our entities can use under different situations. Finally, at the highest level we have strategy, strategic, it can also be tactical thinking. Very much this is about how you coordinate behavior between objects. We'll look briefly at a few different forms of technique in this area, but not in a huge amount of detail. Most of the games that we're doing won't have a particularly strong strategic element to them. We're going to finish off now by going through a few common 2D game genres and to briefly identifying some of the typical forms of AI within each of those genres. And we'll start off just by classifying what types of AI we're talking about. We've done part of this already. So perception is going to be one. In some games, it's going to be important for entities to have a way of sensing the world, or only being able to see what is a reasonable portion of the world, or to detect what is a reasonable portion of the world. Steering is about how our entities will move about within the world that they find themselves. Action is about the action processes where they may be able to put into effect a number of different types of activity or action. Pathfinding, about how you actually plan a route through the environment that your steering algorithms could then implement. And decision making, all the way from individual characters up to the higher level tactical strategic decision making, deciding which action is the most appropriate one to use at a point in time. So these are the categories of AI that we're going to then align against our different 2D genre. So we'll start off first of all with your typical top-down or side-on shooter. Within this style of game, some of the most common forms of AI are perception, by being able to work out, well, something heading towards you to move out of the way. Steering, quite a lot is movement based, about, well, how do you move around within the environment? And firing, I mean, are you firing at random? Are you trying to lead shots? Are you trying to aim in a particular direction? Little aside in terms of this style of game, sometimes there's very little AI. Sometimes the waves come in and move about in fixed patterns. It could be curved, random, curly patterns, but it's more pattern based than sort of AI determined in terms of the movement. Next up we have racing games. For racing games, perception's important about working out which cars are around you if there's a corner coming up. Obviously steering, about how you actually drive around the track without going off it, how do you overtake. And decision making about, well, when's the right time to brake or to overtake, or those types of decisions. For platform games, a few things in platform games. You might have perception about a character, working out, well, can it see another one to chase it? Steering, things like jumping, about how it moves around within the environment. There may be some shooting or aiming involved within it, really just depending on the platform game. The aside here is that for a lot of platform games, there's little AI. Most of the opponents move in fixed, predictable patterns. And the challenge to the player is more in terms of how he or she controls the character in terms of the timing and the movement to overcome the entities within the world. For strategy games, now these could be real-time, could be turn-based. There is arguably quite a lot of AI that comes in. It can be in terms of perception. Maybe some tiles block movement. There may be fog of war. So about working out what a character can plausibly see, or an AI can possibly know about within the world. Steering, about how you move through the world. Pathfinding, about planning out longer routes. And a whole host of potentially tactical and strategic analysis about how you actually coordinate your components within it. There's not much difference between real-time and turn-based. The same types of algorithms are used. Additional constraint for real-time in that obviously it has to work in real-time. With turn-based, you can arguably go into a bit deeper analysis because you can spend a little bit more time. For beat-em-up games, actually it's fairly straightforward. It's generally decision-making. Characters have a range of decisions. They could move forward, they could jump, they could block, they could kick or whatever. And you're simply deciding what's the appropriate action to take at a particular point in time. And we'll be looking at some of the things like finite state machines, which are a good basis in which to do this. Out of all of the genre, artificial intelligence can be adaptive. It's the type of thing that can learn and change. For beat-em-up games, they actually offer a good platform within which to try to adapt to the player. So you sort of learn how the player reacts, and then you change your behavior based on that. For sports games, few different things here. It depends on the sports, but certainly you can have sort of steering, about moving around within your play area. Decision making is a big component of it, as is the tactical analysis. So it does depend on the sport. Sort of double-edged sword with sport. In one sense, it's easy to find expert knowledge. Generally, for most sports, there's a large body of expert knowledge about, well, what type of decisions ought you make, what type of tactical analysis should you perform. So there's a lot of stuff out there. The other side of that is that there's also high expectations that if you're doing a sports game, that it does play at a level of competency that is comparable to actual people playing the sport. So the bar is notionally a bit higher in this style of game. Key takeaways, there's only one here. AI, it is a broad area of study within computer science. Most certainly applies to games, and for a lot of games, it's the thing that brings the game entities to life, that makes the game actually enjoyable and interactive. So